In this question, we're told that a particle moving in a straight line with speed 5u undergoes a uniform deceleration for 6 seconds, which reduces its speed to 2u. It maintains this speed for 16 seconds before uniformly decelerating to rest in a further 2 seconds. We're first asked to sketch a speed-time graph displaying this information. So we'll go ahead with our axes. We need a vertical velocity axis and a horizontal time axis. The two velocities we know of are the 5u and the 2u. It started at 5u and it decelerated to 2u in the initial 6 seconds. So this time period here is 6 seconds. It then had constant velocity and it maintains that for 16 seconds. And finally, it decelerated to rest in 2 seconds. So here's everything that I need on my diagram. Velocities and times all indicated. Part B asks us to find an expression for each of the decelerations in terms of u. So there's deceleration at the beginning. Let's call that first stage, stage A. And we can find the acceleration or the deceleration using this Suvat formula. We want to know the change in velocity. So the final velocity subtracts the initial velocity divided by t, and we'll have 2u minus 5u divided by 6. That gets us negative 3u over 6, and that's negative u over 2. The other time that we had some deceleration is part C of the journey. And in part C, we can do the same formula, and we'll get 0 minus 2u over 2 equals negative 2u over 2. So the deceleration or the acceleration is negative u. The next part of the question, we're told that the total distance traveled by the particle during this period of motion is 220 meters. We must now find u. Well, now that we know the total distance, we can use the fact that distance is going to equal area in a velocity time graph, in a speed time graph. So the distance traveled must equal the combined area of these shapes. The shapes we have a trapezium, a rectangle, and a triangle. Let's add the dimensions. So 5u and 2u and 6, 2u is 16, 2u and 2. And now for each of these shapes, firstly the trapezium, a half, the parallel sides added together, multiplied by the distance between them. We're then going to add on 2u multiplied by 16. And then finally, for the triangle, half of the height times the base. It's going to expand and simplify. 21u, 32u, and 2u. 220 equals 55u. And there we have it. U equals 4. So if we go back to the original diagram, we actually have velocities of 8 and 20. So if we needed to do anything further with this diagram, anything further with this context, we know the numerical velocities.